So let's expand x in terms of the UK basis. I can always write x as the identity times x, because you can always multiply by 1 as many times as you like and you don't change anything. I'm now going to expand both of these using the completeness relation. And here's where I completely fail to make a critical mistake, which most people will make in the exam. When I write the next sum, if I was to write k again, if you just write out exactly the same thing again, then of course when I have something here, if I was to write uk, then I wouldn't know whether that k was the same as this k or from this one. And so I definitely have to change my dummy index, and that's valid. Okay, so now we just expand that out, noting that wherever I have the sum can come right out, and whenever I have uk times x times uw, because x times uw is just a state, that's just a bra and a ket, which is a complex number. So we can gather them together, by which we can see this is just a complex number, so these are the coefficients, and this is x expanded in a general basis, so it's got all combinations of a bra going to a ket. Now suppose we wanted to expand it in terms of the VJs instead, then we could have just followed this exact process, except instead of having the U's we could have used the V's, and so we can see, sort of without having to go through that in detail, that that's just going to come out to this. But we could have gone to this form from here if we'd been bloody minded. We could have put in, see, this is in the wrong basis and that's in the wrong basis, so I could pre-multiply and post-multiply by 1 again. And then I can expand these ones using the completeness relationship for the VJs, using yet more dummy variables. And then all the sums can come out. We note that these are just complex numbers, and therefore they come out. We note that they've got a bra and a ket, so that'll make a complex number, so that will come out. And here we have a bra and a ket, so they will be complex numbers, so they'll all come out. And you'll note that these are just a whole bunch of complex numbers, and so we've in fact got this into the V basis. Obviously, we've made things a lot more complicated here, so this must simplify down at some level to this. And so we could call that a rule. We've just proved that somehow that simplifies down. But in fact, we can use our completeness relationship backwards if we like. To do that, we note that these are just complex numbers, so we can rearrange them how we like. And then we note that we've got the UK combos again, and I've got the K and the W sum there. And I've also got the UW, and I can put those sums right around there, because again, everything's linear. And then I can see from this that that is simply 1 due to the completeness relation, and so is that. Note it's a different completeness relation. I put in the things using V, and I'm pulling out the things using U, because the completeness relation is true in all bases. And that, you can see, is exactly the same form as that. Obviously we've got P's instead of K's and J's instead of W's. They're all dummy indices, so they're all, since we're summing over them, we can transparently change from one to the other. And we've got how to change basis.